This is John Gardner with Transcend Computing. I'd like to show you today how to use StackStudio and TopStack for cloud operations across multiple public and private clouds. Both of these projects are publicly available on GitHub. We're always open to pull requests or suggestions to improve these tools. StackStudio is a user interface for clouds. It provides a single pane of glass to administer multiple public and private clouds, as well as improvements in workflow, governance, and ease of use over the basic cloud operations consoles. TopStack is a suite of projects to provide advanced services on top of core cloud infrastructure services to allow any cloud to provide self-service components that an application might need, such as automatic scaling, load balancing, as well as specific services like databases, caches, and queues. TopStack is implemented as a set of runtime services and in addition supports an API that is 100% compatible with Amazon Web Services. Any tools that are designed for Amazon Web Services should also be able to operate with a TopStack enabled public or private third-party cloud. I'll begin the demo by logging into StackStudio. The initial screen of StackStudio starts you off with your first cloud credential in the compute service. So we're viewing the currently running instances available through Amazon. We can choose different cloud credentials that we've configured for our account or select different regions. You can also dive into the other services that are available. We have relational databases, SimpleDB, load balancing, all the primary services you would want from the Amazon suite of services. We also support OpenStack as a native cloud in StackStudio. We have a set of native services here, as well as the TopStack enhanced services in this second region. In the same way as Amazon, you can drill down and look at the instances that are present in the compute service. You can also deal with elastic IPs, security groups. There's storage available, network services, and so on. We also support the Google Compute Engine. This is a recently released service from Google that offers the same sort of infrastructure functionality that's long been present in Amazon Web Services. We have Compute Engine itself, which manages the instances that you're running. And we've got a couple of sample instances here, as well as images, disks, networks, all of those core infrastructure services. So far, I've only been viewing existing assets on the cloud. Let's make an active change to our cloud. I'll create a new instance, give it a name, pick an image type. This image won't do much, so we'll make it a small, put it in the default security group, and create the instance. This instance will start off in a building state as the cloud spins it up, but shortly it will become active. And now it's active. Let's also associate a new IP address with our instance. So this is the instance we just launched. We're going to give it the IP that ends in 38. And now it has a publicly accessible IP address. We can also create volumes. I'll create a new block of storage. Three gigabytes. No snapshot. And now OpenStack is carving out some disk space for us to use to attach to instances. This covers some of the basics of creating resources on the cloud. One of the common concerns once we have this ability is how do we manage the cost and resources allocated to our cloud to ensure that users don't overrun our cloud and consume it all. We can control that through the governance features available in StackStudio. These are available in the admin area. I'm logged in as an administrator, so I can go to our policies and we can create a new policy. We need some sort of AWS credentials in this case because this is an Amazon cloud to populate the possibilities here, but this policy will obviously govern any credentials associated with the policy. You can deselect particular regions to remove those regions from the list available to the user, as well as selecting a default region. In addition to that, you can disable particular services entirely. No users within this policy will be able to access the services that are deselected here. You can also choose a set of golden images that will be the only images available for users on the cloud. I'll configure a couple of images here, and now this is the only 2 images that will be available to users under this policy. You can choose to limit users to particular quantities of instances of different types, as well as limiting the maximum number of instances in an auto-scale group. It's also important to ensure that the network configuration is respected, so we can insist that all users create resources in a VPC, as well as prohibiting ordinary users from being able to make networking changes to virtual private cloud. We can choose to have particular SNS topics designated as informational warning or error topics. And we can choose to limit other aspects of individual services. Tagging supports assigning automatic tags to instances, to resources created by a user under this policy. So I can ensure that all users will have their username attached to what they create. This is helpful for tracking back leaked resources to the person responsible. And finally, we can create prototype alarms that will become alarms associated to every instance that's created under this policy. We'll say CPU utilization greater than 95%. We want that to be a warning. Now, this alarm will be attached to all EC2 instances launched under this policy. I can save this policy, and then we can navigate to the group administration, choose a group. This group consists only of my user account, but we can change the policy to the policy we just created. And now all of the resources I create on the AWS cloud will respect the constraints we configured. We've talked about maintaining basic resources on the cloud, but typically for significant size organizations, you want to build from more higher level concepts than IP addresses and virtual machines. StackStudio offers some workflow around composing more sophisticated applications from these base level resources. It starts with packed images. We can create a packed image. I'll call it. The critical aspect of these is that they support multiple clouds. So we can target clouds, pick a particular operating system, and choose other aspects of that virtual machine, as well as bake in some initial configuration management solution. This is all designed around making an image that will be useful for many users of the cloud. For advanced configuration beyond basic images, we use assemblies. I can choose to start with a base image that has been uploaded. I'll go with my base image, and we'll use Chef as the configuration management solution. We also support Puppet and Salt at this time. With my base image, I know it's got a Chef client on it, so I will add ActiveMQ cookbook and maybe a particular recipe from the Ant cookbook. Now when we save this assembly, it will be available to compose into stacks or applications. I won't create a stack from scratch. I'll select an existing one. This is a sample with some resources already configured. We've got a palette of available components to add to a stack, as well as the assemblies that we've built previously. I can choose to add an auto-scaling group or a launch configuration. All of these assets are available to compose into a template here. We're using Amazon CloudFormation as the language for designing a stack, and if you run a stack, it will go to CloudFormation as the implementation. We can save this stack, and now make this stack available to other users in the organization as an offering. I'll select my stock app. The offering includes various metadata about the stacks involved. We can include support, pricing, licensing information, that sort of thing, and select the stacks that are included. These offerings can then be exposed to other users by being packaged into a portfolio. A portfolio is simply a collection of offerings that we can make available to particular groups of users. That's a basic workflow around composing more complex applications using StackStudio. Let's talk more about the TopStack suite of services. One service is the monitor service. We actually provide an interface to that within the compute service over here, but it is in fact a TopStack service. We can pick one of these instances that's been running a while, select the monitoring tab on the instance, and you will see that we have information about the CPU utilization, disk activity, network traffic in and out for this instance. This instance is fairly idle, but if it were more active, we'd see that activity here. I'll also demonstrate today TopStack auto-scaling. We can create an autoscaling group. I'll give it a name. And we'll choose an image to scale up. And these will be small machines. We'll leave them in the default security group. For elasticity, we have a number of options. We can choose auto recovery, which simply ensures that one instance is always running and restarts it if it fails. We can choose a fixed array. We want this to be 5 machines at all times. Or we could choose a full-on auto-scaling group. I'll start with 1, scale it up to 10 instances, and set an initial capacity of 1. We can choose to trigger scaling by monitoring CPU utilization or metrics such as that, but for this demo I'll just scale it by hand. You can also disable monitoring. So we've now launched a auto-scaling group. It currently consists of no instances, but the TopStack services will monitor this group, see that it's not scaled appropriately, and begin to spin up instances to match. We're starting with 3 instances, and now we see that a new instance has spun up to join our auto-scaling group. Has this instance ID, and we see the auto-scaling group has exactly 1 instance. The monitoring is continuous, so we can choose to simulate a failure by terminating this instance with the native tools. The instance has been terminated, so now our auto-scaling group needs a new instance. And now there is a new instance that has been created to fill out the auto-scaling group. And our auto-scaling group is again happy with all the instances it needs. I'll also demonstrate today scalable load balancing. We can create a load balancer. We start off with a default of a listener on port 80 forwarding to port 80. You can create additional listeners or modify listeners to load balance different sorts of traffic. I'll set my health check to go to the root, and otherwise leave the defaults. So we've created a load balancer. TopStack will spin up an instance to serve as the load balancer. We use Chef as the configuration management solution behind the scenes to populate this instance with the necessary configuration to be a load balancer. You can see we have a new instance in our instance list, and the new instance now has an IP address. This load balancer doesn't actually have any instances behind it, so it's not very interesting. But let's add some instances. I previously launched a couple of simple web servers, so we can register those. These are simple web apps that just show their IP address on the home page, so we can tell we've gotten to the right instance. Now I can take this load balancer, surf directly to that IP address, and we've hit one of our web instances. if I take the same IP address in a new browser, we've hit a different IP address. So we have a load balancer distributing our traffic across virtual machines in our cloud. I'll also show you today the relational database service. We have parameter groups and security groups. Here's the default parameters for MySQL. So we can supply all the basic settings that are required for a MySQL server. I'll create a new relational database. We'll use MySQL as the engine. We'll make this a medium instance. We'll give it 5 gigabytes of storage. Since I'm not very creative, we'll make the user user and the password password. And we'll name the schema DB. We'll leave it in the default security group, which is open to all users on our network. You can choose to modify the backup window, backup retention, maintenance window. We'll just leave those as the default. Now this instance is currently in the creating state. So TopStack is spinning up an instance to serve as this new database server. And again, we're using the Chef configuration management tool to deploy MySQL software, inject the configuration appropriate for MySQL, including the defaults that we supplied, set up the security configuration, and then we're operating the cloud to create the security groups necessary. Here's the RDS instance that has been created. There's a new volume that's been allocated to store our new database, and it's now attaching to our instance. And within a minute or so, we should see our new database become available. And now our new database is available. I'll start up MySQL Workbench and create a connection to our new database. Set the user as user. We set a password, and default schema. And we can create a table in our new database. We've got a new table. Okay, so I hope you enjoyed a quick tour through the functionality available in StackStudio and TopStack. Check us out on GitHub and let us know what you think.